The GAST name is not just a name, it's a brand, and it's a brand we can put proudly on our products. And the lab team is crucial in reaching that standard. The lab is valuable because it is the thing that ties the entire factory together. Without the lab, we can't do new product development and testing and ensure that the quality of our products that are going to be going to our factory workers is going to be the standards and ability for them to be able to assemble. The first stop on our tour is going to be the large environmental chamber. That machine is able to control the temperature and the humidity of the environment inside of it. So our general accepted ratings is to keep these in a 0 to 40 degrees Celsius environment. We also want to be able to test our units to the extremes. So with the use of this system, we can actually go beyond that and ensure that our systems will function properly and safely for the use of our customers. The applications range throughout the world, so we need to be able to test what is going to happen to these systems if it's in Mexico in the summer, or if we utilize it in Canada in the winter. So those extremes can really affect systems, especially electrical systems. So here we can actually see where our air temperature is inside the chamber. This can be set to whatever temperature we'd like to be set at. And we have a deviation range that we can also utilize. Over here is where we can see our current humidity, be able to remove or add humidity as necessary. If we run into any issues inside there, any system failures, we'll be able to capture what happened in the system or the environment around it. So the next stop is going to be the dynamometer room. In here we have various systems that can capture the torques of an actual motor. We can test very small motors that would be on handheld units to much larger systems that can be used in applications such as medical or dental. For this unit here, we're able to spin it at greater speeds, such as 5,500 RPM, which allows us to do that accelerated testing. So instead of taking months or years to be able to get that wear and tear that we want to see, we can accelerate that to a month or two. So on our controller, we're going to go ahead and we're going to start the system up to start spinning.
I'm hearing this dynamometer turn the air compressor. It's very interesting because you don't hear the sound of the motor. All you're hearing is the sound of the air compressing and exiting the exhaust port.
So our next stop is going to be our endurance cells. Our first one is going to be our air motor room. In here we are testing long-term endurance effects on air motors, so that'll be capturing what the effects are on the bearings and the vanes that are in the inside. The next cell will be our hot box room. So in our hot box cell, we utilize 40 degrees Celsius inside of a captured area to ensure that the life expectancy of the motors and the designs of the systems meet the expectations. The third room will be our larger 2-story room. In this, we have a controlled environment. We have an air conditioner that runs constantly to try to keep it at about 70 degrees Fahrenheit. In this room, we have 2 stories, so we are able to capture a lot of units running at the same time. So our next stop is going to be the anechoic chamber, which is our large sound room. We have a smaller version of this as well, but our main focus is going to be the large sound room. So as we set up the microphones to capture the data from the compressors themselves, we utilize a meter-long stick that has a level on it to ensure that we are directly 1 meter away from the compressors. This is a standard that we follow on all of our systems to ensure that we are able to compare one system to another and know the true values of those sound levels. So the benefit of the foam is that it reduces excess noise and reverberations. This reduces any outside factors, as you have to have more than 10 decibels difference from your ambient noise to your actual noise you're measuring to be able to capture true data differences. So as our next stages of the tour continue, we're going to walk past our technicians' offices. Each area that we visit has a master technician assigned to it. That allows for these individuals to learn more about these areas and focus on them so they can become a master journeyman of that area. Okay. So as we're looking at each of the technicians' offices, they're not just offices. These are where they actually do a lot of their work. So in these spaces, you'll see that we are testing these units. We are able to capture voltage, amp draw, watts, pressure, vacuum, airflow. When we are doing this, these are the things we're looking at to ensure that our test spec data that we produce for our customers is accurate. So our next stop is going to be our UL lab. So UL stands for Underwriters Laboratory. This is a certification you can find on most any electrical product. It's a safety standard that we do adhere to at Gas Manufacturing. The great thing about having UL in-house and having certified master technicians is that we can do the testing ourselves. So we are at the UL laboratories here at Gas Manufacturing, and we have our master technician, Jack Kemp. What is the benefit of having UL testing here at GAST?
Saves a lot of time and a lot of money.
So if we were to send a test out, about how long does that roughly take? Usually if we send one out?
About 3 months.
Okay. So if you started a test, how long does that take us, and how much time does that reduce?
Depending on what I have to do, anywhere between a week to 2 weeks.
So that is a great reduction and a great benefit to having gas compressors and everything in-house.
Yep.
As we are doing the testing in-house for the UL lab, we are able to identify any issues we run into and focus on improvements instead of waiting for UL to send us back the product. This really increases our efficiency and reduces the downtime on systems that are being tested. So our next stop is going to be the model shop. The model shop is important to control lead times on creating new products. It is vital to ensure that new products can be developed quickly. We'll see JR, he's going to set up the milling machine to be able to mill some billet stock down into an actual rod.
So we'd start out with a piece of raw billet. We'd start off in the horizontal saw, we'd cut it off. We'd come over to the lathe, we'd turn this end, we'd flip it, turn the other end, and then we'd take it over to a mill. We'd set it up in the mill vertically. We'd mill the flats on it, and we'd do some of the top work there. And then once we're done with that, there is a center that we use in there along with an indexer. So then it would sit in the indexer like this, and then you would eventually end up with this part out of the mill, and then we would run it through the shot blaster and through the tumbler.
So how long usually does that process take?
From billet to part complete, probably about 8 hours for one part.
Wow. And if we were to try to outsource and have someone else do that, how long do you think that would take?
I honestly don't know.
Well, probably a lot longer than having us do it.
More than likely, and then you have lead time on top of that. Yep. So.
And they're not our only customers, so we'll have to wait in line.
Yes.
Gotcha.
So in order to use a milling machine, most factories will know there's a high level of precision and skill that is needed to use these machines. As we see, JR is going to be calibrating the machine in order to create cutouts of our 120R system so we can see the internal structures and model of the system functioning. This is another benefit of having the model shop here at Gas Manufacturing. So thank you for joining us here at Gas Manufacturing. That is our pneumatics lab, along with our model shop where we do a lot of our prototyping and rapid events. My name is Rob Bader.
My name is Riga,
and we'll see you.